Hey, so do we really need the graph databases? Yeah, for sure, we need the graph databases. We love them all. But with the graph databases, we have two big challenges. First of all, when you're trying to select the graph database, you're already bounded to the tough decision that quite often you couldn't make immediately. That do we need to go more RDF stores and work with triples, or do we want to have the property graphs? And the problem with this RDF stores versus property graphs, it's so tough. It's even harder than find the couple in your life and all other things. So people are so stressful to make such decisions because you have no way to change your mind. And actually, I wrote the article about the state graphs and actually layered graphs that try to marry these two concepts and give you the building blocks for the databases that could use the property graphs of the RDF stores in the same time. And actually, Neptune right now from Amazon support this approach, but they not giving you the capabilities to switch the languages and switch the tools. So maybe it will come next. But right now they store in a way that you could have them triple store together with the property capabilities and all those things. But getting back to our original question, do we really need a graph databases? And to be honest, I faced with this question and challenge more than 1.5 years ago when we started our project at MyKeen, and then we clearly see that we need the knowledge graphs, but my challenge was that we need them on device. And all these amazing things like Neo4j, OntoText, and bunch of other databases simply doesn't have any kind of graph capabilities that could be run on the user device. They all could be run on the server, and then I really had the tough times. But I was lucky. We found the CosoDB, and CosoDB it's this multimodal database that had the vectors together with the relations, but they had the data log on board, and they really show that you actually could model the graph in a relational model in a quite effective way because you have the powerful recursive queries, and they really grab and implement a lot of things related to graphs immediately in the database. And this approach reveals a couple of things. First of all, the relational model could be effective for the graphs. I could not say that it could be super effective for the super large graphs. It's the separate topic for discussion because, to be honest, our graphs are not so big. And another thing that maybe you not always need a graph database, but some graph databases are the combination of the storage and powerful graphing engines, and they implement a lot of graph algorithm in the bare metal C or C++ and make it blazingly fast. So they give you the graph engines and graph processing capabilities. So my quick answer to this question that sometimes it doesn't really matter how you store. Sometimes it's really matter how you process. And sometimes instead of graph databases, you need to have the graph engine or graph processing or graph streaming processing capabilities, and a lot of frameworks and tools is about this, that they load your data to the graph and then process them and all those things. And Coso was the first thing that they say that you could grab the data log, effectively do recursive queries, and build something that represent your graph with the directions and weights, and then give it to our graph processing algorithm and get the answers back. And for me, it was mind blowing. And then, unfortunately, we figure out in some point of our journey that CosoDB is amazing, but the community support is not there, the team is not reacting on the bugs, the most effective, most active guy who answering to the issues actually is me, and to other people, right? And we just take the tough decision to switch back to the SQLite, and we choose the relational database that doesn't have the graph engine anymore, and it means that you need to implement your graph engine yourself on the application layer. And yeah, that's a big challenge, but still we're capable to run the graph algorithm in the relational model. And that was the biggest discovery. And if you will take a look to the modern databases, they more and more go to the multimodal approach. And I believe that future of the databases is multimodal. But even another movement that I don't really believe that in a modern world we really have the pure relational databases. We don't have them anymore. If you will take a look to the Postgres, it's not relational databases. It's object relational database. They operate with objects, and with extensions, you could have the graph capabilities in Postgres also, and turn the Postgres to the graph database. Also, what I see that right now, the latest standard of the SQL already have the graph capabilities and GraphQL as a part of the SQL. So we bring the graph query language to the relational model, and in this space Oracle really excel. So Oracle really capable to give you the RDF like representation on top of the relational database, or they capable to give you the property graph on top of it, and all other things. So you could see your relational data that's stored in the tables in a completely different way just with the Oracle tools. And to be honest, the Microsoft are doing the same. They already have some graph capabilities that you could describe that this table is a node table, this table is an age table, and start doing the graph queries. And the same as actually DuckDB could do, and DuckDB have also a lot of graph capabilities. So we could not say that we have pure graph databases right now. We have a lot of relational databases that have some object and graph capabilities, and maybe they're good enough for your use case. And what I really am keen to see is the databases that are able to run on edge device that combine the graph together with the vector store. And what I really want to see that in some point the SQL will bring the latest SQL standards together with the graph query capabilities to the regular SQL, but we're not there unfortunately, and I still couldn't write my graph queries when I use libsql or something like that. But I really keen to see such things. But I see more and more that the age between the pure graph database just vanish, and we talk more and more with the graph providers that you could not have the pure graphs anymore, because for the artificial intelligence agents you need at least to build the RAG for appliance. You need the graphs, but you also need the vector search and semantic similarity, right? And this opened the door to the new generation of the storages that somehow combine the multimodal capabilities. And the future is the multimodal. We have quite interesting stuff with the Terminus DB and Terminus Link and all other things. We have some interesting capabilities with TypeDB. We see that more and more good old Prolog and Datalog are getting back to the game, and yet another quite interesting domain is Postgres as a platform. So Postgres is not a database anymore, it's a platform that really allows you to do the crazy things together with even the HTTP interface to the database, and exposing the database as REST APIs and all those things. Maybe it's too much to put such things to the database, but we have this capability, and Oracle go this way. for agents. They have a lot of products on top of the classical relational database that you don't need to go and buy. And I pretty much sure that it will be the future. So the future is the multimodal. Do you really need the graph database? Depends on your use case. Maybe you could, you need something more, and maybe you even need something more powerful, because if you have the huge complex graphs that have the graph algorithm, maybe you could utilize some cuGraph, the library from CUDA that actually use the superpower of GPUs and process the millions and billions of nodes. And you don't need the graph database for this. You just need to have the capable graph engine. And the same, they have a lot of tools on top of Spark that bring the graph engines to the game, and they capable to find the motifs and complex graph comparisons and all other things. So don't be bounded just to capabilities of your graph database, because in practice you have the agents, you have the graph algorithm, you have the processing of the graph in the worst case on application layer, and all these approaches works. So, and we even able to operate without any kind of graph database at all, and we still successful. So if you want to learn more how we do it, or if you have some use cases that you do something really cool with the graph, especially if they involve the time and time-aware graphs, let me know. I will be keen to talk with you. See you next time. Choose.